Hello, this is Mrs. Poland again. This is Unit 3, Lesson 3, and it's the second video because the lesson was very long. And we're going to be discussing odd and even functions. An odd function has to have an odd degree. In other words, that first term, if the polynomial is in standard form, has to be an odd. But not only that, an odd function, all terms have exponents that are odd. So in this case, the first exponent is 3 and the second exponent is 1. Graphically, an odd function is symmetric about the origin, meaning that if you look at the graph upside down as right side up, in other words, if I turn the paper 180 degrees, let's see if I can turn this graph, to try turning this graph upside down, it looks the same as when I put it right side up. So that means it's symmetric about the origin. So if you rotate your paper 180 degrees and it looks the same right side up as upside down, it's an odd function. Okay, we can also determine it algebraically. So as I said, we can also determine this algebraically. If I substitute a negative x into the original function and it's the same as negative of the original function, then we have an odd degree. Well, what do we mean by that? Here's our original function, 4x cubed minus 6x. Wherever I see an x, I'm going to replace it by negative x. And then I'm going to simplify this. So this becomes negative x cubed is negative x cubed. Negative negative is positive 6x. So that's equal to negative 4x cubed plus 6x. But I can factor out a negative sign. So this is the same as negative of the original function, right? This is the original. Therefore, since f of negative x is equal to negative f of x, we have an odd function. An even function has to have an even degree, meaning that the leading term, in other words, if you're in standard form, the highest exponent is an even number, which it is in the case, so it has to have an even degree. But not only that, all terms in the expression have to be even. So this has 4, this is 2, and even though it doesn't look like it, this is really x raised to the 0. So if the constant is an even term. So we know that this is an even function. Graphically, we know it's an even function if it's symmetric with respect to the y-axis. In other words, if I folded this graph in half over the y-axis, if it looks the same on both sides, it's an even function. And the third way we can tell if it's an even function is if when I substitute negative x into the original function, I end up with the original function. Well, let's see what I mean by that. And again, this was on the August 2017 region, so unfortunately you have to know all 3 ways. So I'm just replacing wherever I see an x, I'm replacing it by a negative x. Negative x raised to the 4th is x to the 4th minus, I left off the square, plus 2. The negative x squared is x squared minus 1. But isn't that just the same thing as the original function? Same thing. So therefore, f of negative x is equal to f of x. Therefore, the function is even. So it has an even degree and it's an even function. Okay, so odd functions not only have the highest exponent that is odd, in other words, it's an odd degree, but all of the terms have exponents that are odd. So it's a special case of a function with odd degree. Everything is odd. An even function has terms with all the terms have even exponents. So these are just some examples that you can see of odd functions. Notice all the terms are odd, all the terms are odd, all the terms have odd exponents. Even functions, all the terms have even functions, even exponents. And neither is when you have odd exponents and even exponents mixed up, like these scenarios. Whoop, I skipped a page. Okay, so for each graph, describe the end behavior and determine if it's an even function or odd function. So this particular graph looks symmetric with respect to the y-axis. So what do you think? It's even. Notice that both ends are going in the same direction and they're both going up. So therefore, both f of x, when you approach it from the right and when you approach it from the left, go up. That means you're going to positive infinity. This function does not look symmetric with respect to the origin. If you turn this right side up and upside down, I can't turn it currently, but I think you can turn your paper and you'll see that it does not look the same right side up as upside down, so it's a neither. Let me get that pen out. And the end behavior, as you go to the right, you're going up. And as you're going to the left, you're going down. Now the next one. This is symmetric with respect to the y-axis. With respect to the origin, so it's odd. As you go from the right, it's going down. And as you go from the left, right, you're going up. Next page. Which of the following are even functions? There could be several, not just one choice. So I'm putting it on hold. You do the same and try. This function is neither, right? Because you have odd and even. This is all even, right? Remember the 51, that constant has x to the 0. 0 is an even number. This is odd. This is odd. This is, if you FOIL this out, you would get 9x squared minus 12x plus 4, so it's a neither. This is definitely a mixture. And this is a constant, so this is even. So B and G are the answer to that problem. Select all that apply. Well, we see that the ends are going in opposite direction. That means it has an odd first term. So that works. Does it look symmetric with respect to the origin? It does to me. Can't be an even degree. Can't be an even function. And we could see that you're rising to the right and falling to the left. That means it's a positive degree. And there you have your answer, A, B, and E. Let's do this one. We see that both ends are going in the same direction, meaning that you have an even degree. So this is wrong. Can't be an odd function then. It's symmetric with respect to the y-axis, so that works. And since both ends are going down to negative infinity, that means it has a negative leading coefficient. So the answer is C, D, and F. This is a common regions problem. This particular one is from June 2016. We see that both ends are going down. That means it has to have an even degree. So that can't be the choice because that is correct. We see that since both ends are going down, the leading coefficient is actually negative. So that's probably our answer. There is definitely a relative max. There are actually two of them, 1, 2. And there are two intervals where it's decreasing. It's decreasing here, and it's decreasing here. So that's for the answers choice 2. And I will let you try the homework on your own.